All right, sorry for that brief pause. I found the paper now. So let's look at the example. It asks us to show that the function f of x equaling 1 minus the square root of 1 minus x squared is continuous on the interval -1 to 1. Okay? Well, if -1 is less than or equal to a is less than or equal to 1, then we could say the limit as x approaches a of f of x is the limit as x approaches a of our function, which is 1 minus the square root of 1 minus x squared. We're going to use our limit laws, and we're going to say, okay, well, that could be said when I take the limit, I'm going to get 1 minus the limit as x approaches a of the square root 1 minus x squared, okay, which is equivalent to 1 minus the square root of the limit as x approaches a of 1 minus the limit as x approaches a of x squared, which is 1 minus the square root of 1 minus a squared. So 1 minus the square root of 1 minus a squared, which is f of a. Well, by the very first definition of continuity that we talked about, we have shown that it's continuous on that interval. So by the first definition, f is continuous at a if -1 is less than a is less than 1. So we just proved that. All right, moving on. We have another theorem we want to look at. And this theorem says if f and g are continuous at a and c is a constant, then we could say the function f plus the function g, or the function f minus the function g, or a constant times the function f, or the functions multiplied together, or the functions divided, where g of a is not equal to 0, are all continuous at a. So if we know f and g are continuous at a and c is a constant, then we could add the functions, subtract the functions, multiply the functions, divide the functions, or multiply the function by a constant, and they'll all still be continuous at a. Okay? The other theorem we have that says any polynomial is continuous over all reals, and any rational is continuous over its domain. And let's look and see what that does for us. If you are asked to find the limit as x approaches 3 of the function x cubed plus 2x squared minus 1 divided by 3x plus 5, the first thing we're going to say is, well, this function is a rational function, okay? This function here is a rational function. So we're going to have to see what is the domain. The domain is x cannot equal -5/3, okay? And remember, we find that by setting the denominator equal or not equal to 0 and solving. So the domain is going to be all reals, x cannot equal -5/3. Okay? Well, therefore, we could say, if we're looking at the limit as x approaches 3, well, 3 is not -5/3, we could say the limit as x approaches 3 of x cubed plus 2x squared minus 1 divided by 3x plus 5 is equivalent to saying f of 3. And so all we're going to do is wherever we see x, we're going to plug 3 in. So we're going to get 3 cubed plus 2 times 3 squared minus 1 divided by 3 times 3 plus 5. Using our algebraic skills, we'll see that that simplifies to 44 over 14, which is 22 over, and that's a 7. We're going to stop there for today. So again, just to recap, today we've talked about the squeeze theorem and we've learned about the continuities.